All right, we're talking about two-step equations. We're talking about something that looks like this. Okay, the reason that it's two steps is because you have multiplication and addition both in the equation. Okay, so we have, right here would be multiplication. Then obviously here is the addition. Okay, so when we're solving two-step equations, you will always solve the addition or subtraction first. Then solve the multiplication and division. Okay, so on this one, 2x plus 10 equal negative 18. Okay, the addition we have to do the inverse of. So we have 2x plus 10 minus 10 equals negative 18 minus 10. Okay, so here's the addition, here's the inverse of the addition. Those two things cancel each other out. Okay, that leaves me with 2x is equal to negative 18 plus negative 10. Okay, once again, we have to change this to addition and do the opposite of 10, which is negative 10. Doing the opposite of a positive, and that is a negative. So that gives us 2x is equal to negative 28. So that's the first step. Okay, the second step then is to do the inverse of multiplication, which is division. 2 over 2 cancels, leaving me with x. 2 goes into 28. How many times? 14. And that would be negative 14. And so that gives me x is equal to negative 14. Okay? So I want you to try this one. Very similar to that one, just different numbers. Okay, so see if you can follow the steps and solve 9y plus 4 equal negative 14. Okay, who has an answer? Zach? Negative 2, that is correct. Now, let's see how we got negative 2. We start by saying 9y plus 4 minus 4 equals negative 14 minus 4. Okay, on the left side, the plus 4 and the minus 4 cancel each other out, giving me 9y equals negative 14. Change that to addition. Do the opposite of that, which is negative 4. So it gives me 9y. I have two negatives. I just simply add the two negatives together, which gives me negative 18. Second step is to divide both sides by 9. The 9's cancel, giving me y is equal to, 9 goes into 18 2 times. There's one negative sign, so it's negative 2. Any questions over that? Nothing? Okay. All right. Now, as we look at this problem, 29 minus 2x equal 13. Okay, we want this 2x to be first in the problem. So to do that, I'm going to do this. 29, change that to addition, do the opposite of positive 2x, which is negative 2x. Okay, now I'm going to use the commutative property because I want that variable to come first. And so I'm taking it and doing it this way. Okay, now solve. Okay, because I want that variable to come first because that's just the way it's easier to do it that way. There's another way you could do it, but I don't really want to share that with you right now because I'm afraid it might confuse some people. So now I just solve it. So I solve it by going negative 2x plus 29 minus 29 equals 13 minus 29. Plus 29 and minus 29 on the left side cancel each other out, leaving me with negative 2x, and that's equal to 13 plus negative 29. Okay, because this is addition, do the opposite of positive 29. And the opposite of that is negative 29. So now I have negative 2x is equal to negative 16. Because you have a positive and a negative, you have to subtract their absolute values. Now we solve for x. Divide by negative 2, divide by negative 2. X is equal to 8 because you're dividing negative 2 into 16. Huh?
Why do you switch it up at the beginning?
Okay. If you don't. Okay. If you take 29 minus 2x equal 13. Okay. What are you doing to 2x? No. See, there's your problem. You said we're subtracting it from 29. Or you said you're subtracting 29 from it. You're not subtracting 29 from it. So, can't do it that way. Okay, so what else are we doing then? Because realistically, we've never had a problem. See, you've never had a problem that looks like this. Let's go back to our one-step problems. 3 minus x equal 4. So y'all have never had a problem like that up to this point. It's always been x minus 3 equal 4, right? And so you knew what to do there. Well, if you think about it logically, okay, if you think about that problem logically, what can we do with 3 and subtract something from it and get 4? What does the something have to be to go 3 minus something is giving us a positive 4? Has to be a negative. It has to be a negative what? No. No. What?
No, hold on.
No, what'd you say?
7.
Yeah. Has to be a negative 7.
Well, yeah, I knew that.
Has to be a negative 7. So basically then what you did is you just took these two and put them together. Okay? So when you have the minus sign in front of the variable, it becomes a different type of problem. And so you have to take that extra step of what we did at the beginning. We have to do this step right here because of that, because the minus sign is in front of the variable. Okay, because it gets us back to the one y'all had last night. I think it was, I don't remember exactly, it was negative b equal, was it? Negative 5. Okay. Well, did you just say b is equal to negative 5 then? No, it's 5. Well, same thing we had here. You have a negative 2x, and that's equal to we had a positive 29 over here. So when it came over here, it became a negative 29 right here, right there. And that's basically the same type of deal. You just didn't have the 2 to deal with. But anytime you have a subtraction sign from the variable, you got to go ahead and change it and flip it. Okay, you got to change the subtraction to addition and flip it. Use the commutative property at that point. Okay, because that's the only way that you can solve it correctly. Because you're looking for the, I just slipped my mind. I'm thinking division. Wow, mine just went blank. Second number in a subtraction problem. No, on addition it's the add-ins, and I can't remember. Division, it's dividend and divisor and quotient, and I just went blank. My mind's drawn a blank. I'll have to think about it. It'll come to me in a second. There's a different word. The two things that you're subtracting, there's a different word, and I can't remember what it is now. Hadn't used it in a long time, so my mind went blank. So let's look at this one. 129 equals 12b minus 15. Okay, is on the right side is the variable listed first. Yeah, so we don't have to. It's not one of those type of problems that we just talked about. Okay, it's only when the variable is listed second, and it's really when it's only listed with the subtraction sign. Okay, in other words, if I had this original problem was 29 plus 2x equal 13, you don't really need to do anything there. You can use the commutative property and say 2x plus 29 equal 13. Okay, so those are just two examples. Now back to our problem here, 129 equal 12b minus 15. Okay, well, this is 129 equals 12b minus 15 plus 15, because the inverse operation of subtracting 15 is to add 15. Okay, now I got to do it to the other side. So I have 129 plus 15 equal 12b minus 15 plus 15. So now we've done it on both sides, here and there. Now on the right side of the equation, subtracting 15 and adding 15 cancel each other out. 129 plus 15 is what? 144. So I have 144 is equal to 12b. So what do I do to solve that? Divide by 12 to both sides. That cancels. 12 goes into 144 how many times? 12 times. So b equal 12. All right, let's move to fractional problems. E over 9 minus 3 equals 3. Okay, and the way you need to think about this is this way. Okay, let's think about this. If I just said something minus 3 is equal to 3, what does that something have to be? What? 6. It has to be 6. So in this box has to be 6. Okay? That's what that E over 9, in other words, I have to divide 9 into some number and get 6. Well, what number do you divide, what can I divide 9 into to get 6? What? 54. Okay? So our answer is going to be 54. Here's why it is 54. If we look at the problem, okay, the inverse operation is this. E over 9 minus 3 plus 3 equals 3 plus 3. Okay? Over here on the left side, the minus 3 and the plus 3 cancel, leaving me with E over 9 is equal to 6. So there's that 6 that we talked about in the box. Okay? Now, how we solve it from this point is we're dividing by 9. So the inverse of dividing by 9 is to multiply by 9 to both sides. Okay? And so that means I multiply by 9 over here. I'm going to put it over 1 just because there's a fraction. And then I multiply by 9 over there. On the left side, those two cancel, leaving me with E. On the right side, 6 times 9 is 54. Okay? So now let's look at one with a fraction. 3/8 W minus 14 equals 10. Okay, what do I do first? Owen, what do I do first? Yeah. 3/8 W minus 14 plus 14 equals 10 plus 14. So here's your inverse operation on both sides, the plus 14. On the left side of the equation, subtracting 14 and adding 14 cancel each other out. That gives me 3/8 W equals 24. Everybody understand where we got 24? 14 plus 10? Okay. Now, that gets us back to our statement we talked about yesterday. Right here. Remember yesterday we said there's a special case when you have a fraction in front of the variable. To solve the equation, you must multiply both sides of the equation by the fraction's reciprocal. Okay? So back here then, we have 3/8. I'm going to rewrite it to give me more room. So I have to take and multiply by the reciprocal, 8 over 3, to both sides. Okay? That cancels, leaving me a W equals, you have 24 and 3 that I can cross cancel. 3 goes into 3 one time, 3 goes into 24 8 times. And so I have 8 times 8 on top, 1 times 1 on bottom, which means W is equal to 64. All right, I want you to try this one on your own. If you get it right, I'm going to give you 2 extra points on your homework tomorrow. Hey, you know what 2 extra points are? For like 10%? Yeah, well, just for that little laughter, I just won't give it to you if you get it right. I'll give you a minute or so to do that. Okay, listen up. 2 ways to do this problem. Okay? The first way is to use the distributive property and distribute the 3 to both things inside the parentheses. So that would give me 3 times x plus 3 times 1 equals 12. Okay, so that would be 3x plus 3 equal 12. So now I solve it from that point. There's another way to do it, and I'll show you the other way to do it here in just a second. 3x plus 3 equal 12. Then I take 3x plus 3 minus 3 equals 12 minus 3. These 2 cancel, leave me at 3x is equal to 9. Then to solve that, we divide by 3 to both sides. That gives me x is equal to 3.
I don't know what I did.
Now, the other way to do this is this. You can do the inverse of multiplying by 3, which means you do this. 3 divided by 3 times x plus 1 equals 12 divided by 3. Okay? 3 divided by 3 is 1, so it cancels, leaving me at x plus 1 equals 4. Now you do x plus 1 minus 1 equal 4 minus 1. These 2 cancel, leaving me at x is equal to 3.
I added instead of subtracting. I did x plus 1 minus 1 equals 12 minus 1, then I did 3 times...
Well, no, see, that's what you did wrong. You can't take something out of the parentheses and do it to both sides before you've canceled out the parentheses. So you can't do that like I just did, one of those 2 ways, either using the distributive property or the inverse operation. Either this way or that way. That's the way you cancel out the parentheses.
Who got 3 and 2 over 3?
Nobody. All right. Your homework. Homework is 7.5. 2 through 23. 7.5, 2 through 23.